How do astronauts weigh themselves while floating in space? On the International Space Station, ISS, astronauts measure their body mass, not weight, using specialized devices developed by both NASA and Russia. The microgravity environment in low Earth orbit presents unique challenges for the human body. Its effects are still under study, and astronauts must maintain peak physical condition while floating aboard the ISS. On Earth, exercise routines often rely on body weight. But how do astronauts determine their weight when they are virtually weightless in space? The ISS is equipped with two devices to help with this: NASA's Space Linear Acceleration Mass Measurement Device, SLAM-D, and Russia's Body Mass Measurement Device, BMMD. Both use spring-based mechanics to measure an astronaut's body mass rather than their weight. Weight is the product of mass and the gravitational force acting upon it. For example, gravity on the Moon is weaker than on Earth, so Apollo astronauts appeared lighter while walking on the lunar surface. However, their mass remained unchanged. This is why astronauts on the ISS measure their body mass instead of weight. Mass, like weight, is often measured in kilograms, which can cause confusion. However, mass refers to the amount of matter in an object, regardless of the gravity acting upon it. The SLAM-D relies on Isaac Newton's second law of motion. Force equals mass times acceleration, F equals ma. Located in the European-built Columbus Laboratory Module on the ISS, SLAM-D is part of the Human Research Facility rack, a set of drawers containing integrated devices. SLAM-D extends from the rack via a guide arm. To use SLAM-D, an astronaut secures their feet in footrests, places their abdomen against a cushion, and rests their chin on a head support. Two springs inside a drawer are released, pushing the guide arm against the astronaut and causing them to recoil backward. The force exerted by the springs is known, as they are calibrated to specific specifications. The astronaut's acceleration, as the springs push them backward, is measured by an optical sensor tracking the movement and speed of the guide arm. Acceleration is calculated by dividing the change in velocity over a distance, approximately 1 meter, by the time it takes. A computer connected to SLAMMD then calculates the astronaut's mass using the formula F equals ma with an accuracy of 0.2 kilograms. The BMMD, located in the Zvezda module, also uses springs but operates differently. Instead of a single push, astronauts crouch on the device and bounce up and down like a pogo stick. The oscillation speed of the BMMD depends on the astronaut's mass. Without an astronaut, the BMMD oscillates much faster. By measuring the time of each oscillation, the system can estimate the astronaut's mass. Monitoring body mass in space is essential to ensure astronauts do not lose too much mass. This is critical because humans lose an average of 1% of bone density per month in the harsh environment of space. Muscles also atrophy, and the heart weakens due to the reduced need for pumping blood against gravity. To counteract these effects, ISS astronauts exercise for 2 hours daily in the station's gym to maintain muscle mass, bone density, and cardiovascular health. Measuring body mass helps determine whether these measures are effective and whether astronauts remain healthy and fit during their missions.